All right. Here's the second half of this, because for some reason it didn't go all the way through. We ended, or not we, but YouTube ended halfway through my explanation of delay and disorder. A disorder. Got to get myself back into review mode. A disorder can be a persistent delay, and we talked about that. If you have a delay that just continues to persist past, months and months, a year, past where children should get their speech sounds, that might become a disorder. Then you also have things that can be just like hallmarks of disorders right off the bat. So this would be something like backing. So if you want to say tuck or truck, you want to say tape, and it comes out as cape, right? And this would be backing. That's different. It's unusual. We don't usually see backing, and that's a hallmark of a speech disorder. Also, getting some of your later sounds, if you have those mastered, but then there's some early sounds that are still not mastered, again, that's also indicative of a disorder. So anything that's not part of typical speech development could be a disorder, or at least would qualify for, something that needs to be investigated. You need to collect some speech samples and see, is it a disorder? And then as an SLP, you're going to be the one who basically diagnoses whether that's a disorder or not. But those are the kinds of things that you're looking for. And then again, persistent delays. And then lastly, what kind of feedback is necessary for understanding speech sounds? Visual and auditory are both important. Roughly 50% of each one. It's kind of weighted together. And that's what we're looking for, is a little auditory and a little visual. We average them together for speech sounds. This is what we saw with the McGurk effect. And then, like I was talking about, you can also do that with things that aren't just speech. So the sound of a tennis ball hitting the ground and the visuals of a beach ball hitting the ground, people will perceive that the ball is about the size of one of those red playground balls, like somewhere in between the size of a beach ball and a tennis ball. So they integrate the visual information of how slowly this thing is falling and what it's made out of with the actual sound that they get, and then they kind of put the two together and decide it must have been somewhere in between, because there's a particular sound that's associated with like larger objects bouncing and smaller objects bouncing, and so you kind of average the visual and auditory information just like we do with speech. Of course, the illusions are like the weird case, right? Those are the ones that we have to show how that works. Usually they're delays if you didn't have one of those senses. Okay, next, speech disorders. The difference between articulatory and phonological disorder. Articulatory is most likely going to have a cause because it's something that we can see. So that's answering the third one down. Now I'm going to answer the like what. Like what is like generalized muscular weakness, ataxia, malformations of the speech apparatus, stuff like this. This is all articulatory disorders. They'll lead to not being able to accentuate the words correctly, slushiness or slurred speech, things like that. Phonological disorders, of course, is more of a cognitive problem. It's a word knowledge problem, or sound knowledge problem, like how words go together, putting together phonemes and morphemes. So you would expect that someone with a phonological disorder could make an F sound, and then doesn't use the F sound in the places where they should. So clearly it's not an articulatory disorder because it can be made. It's something that's going on cognitively, and that also includes like behavior training. Like if they just learned it incorrectly, that's still part of that. That's the kind of disorder that you're looking for there. Then, of course, types of articulation disorders. We talked about that. Again, we've got our generalized muscular weakness, problems with the articulators, problems with the resonators, any of that stuff. So we covered that one. What is the first step to understanding a disorder when you're planning treatment? How do you figure out the extent of the issue? I wrote that kind of weirdly, but that's okay because I'm explaining it to you. The first step is collect speech data. You need to look at speech samples. You need to collect speech samples. Listen to where the phonemes are produced. Are they always produced incorrectly? Are they only sometimes produced incorrectly? In what positions are they produced correctly or incorrectly? This is the first step. And you figure out the extent of the issue by counting up number of times that it's produced incorrectly and positions. You can use something like the Goldman-Fristow test. How much data and what kinds? More data is better, of course. The more data you can, the better. And what kinds you want to get the phonemes in all of the speech positions. All speech sounds, all speech positions, right? Is qualitative preferable to quantitative? No. Quantitative is often better, especially if you're trying to figure out like a percentage of time that this person, it's not always a kid, so we'll just say person, produces the phoneme phoneme incorrectly. If you want to know a percentage, you want to know quantitative. That can help you determine how much this is going to impact their life. It can also help you determine, again, like the position that it's happening in. If it's all positions, then this is like a fundamental problem. If it's some positions, then they have the sound mastered in other positions. It's easier for you to try to get them to model that sound in other areas. So quantitative is usually better. Qualitative has its uses, though. You can describe how the sound is being produced, and then that might allow you to think about how to help them produce the correct sound. So let's say, for instance, a slushy S, making the S's over on the side of your mouth or something like that. You can try to teach them how to push the air out, not over on the side of their mouth, but in the front where they need to. So qualitative has its use, but quantitative is often better. What about familiar versus unfamiliar listener? Well, children should be, about 75% of their spoken language should be intelligible to an unfamiliar listener by age 3. And we want to use an unfamiliar listener because familiar listeners have ideas about what's going on. You can put the pieces together, and then something that's produced weirdly to an unfamiliar listener to you sounds totally fine. This is what happened to us when we listened to sine wave speech. The first time you heard it, it sounded like garbage, just like some Star Wars robot, beeping. But then once you knew what it was, you couldn't unhear it. You became a familiar listener. And so that's why we want to use unfamiliar listeners to judge the intelligibility of speech. Okay, what's next? Yeah. Okay, so the silent period in bilingualism, this is the time when someone is they're building their conversational L2. They're silent during this period, but they're kind of taking in information. It's kind of an integral process to learning. There's a lot of listening, a lot of thinking, a lot of trying to figure things out. But it's just a hallmark of people learning the second language that there's not a lot of use going on. That's the silent period. It can look like AST to people who don't know. So let's say that you don't know that this kid only speaks L1, they're L1. They come to the US, or maybe they were in the US, but they were in a different place where they don't, they didn't speak English, though, is summer breaks. So let's say they start the school year, at the normal time. They get about 9 months in. They're kind of getting close to developing conversational L2, and then summer break. So they're not using the L2 as much, and now they're set back even more. So it's not really going to be a year. It's a year of constant use. And without constant use, then that becomes more time. There's not like an easy benchmark to say, after that without constant use. We don't know. It could take 2 full school years. Maybe they remember a lot and it doesn't take 2 full school years. Maybe with some kids it's even harder and it can take 3. So that's the caveat. It's got to be constant use. And in schools, you don't get constant use because you have breaks and stuff. Some techniques to assess SLP issues if you don't speak the child's L1. First of all, see if there's another SLP who does. That's one thing. The second thing you can do is a translator. And if there's no translator, then you can look into the community for parents, just people who speak that language who can come and try to translate for you. And also just tell you, like, what are they, like, are they producing that correctly? Like, if they say this, does that sound come out correctly? Does it sound right to you? What's cool about it, if you use, let's say, the kid's own family, they're familiar listeners, so you end up with a problem there. If you can find other people in the community who are unfamiliar listeners, then you've got an unfamiliar listener who's an expert with that language, and that's great. They can tell you when things are being produced strange or if they're producing it correctly. You'd be able to tell using these methods. If this is just one of those silent period things, maybe they're totally fine. There's no speech issue at all. They speak their language just fine. There's a little bit of accent in L1 when you can get them to, in L2 when you can get them to speak it. No problem. Or maybe there are issues that translate between the two languages. Who knows? Types of bilinguals. Well, we've got simultaneous bilinguals. Those are people who speak 2 languages or more, 2+ languages from birth, or very close to from birth within 1 year of each other. And then you've got sequential bilinguals. Most of the rest of us, we learn one language, then we try to learn the other one. And some of us are really good at it, and some of us are not. I am not. Really only conversational in my one language. Who's most likely to code switch? Simultaneous bilinguals. Absolutely. And then lastly, does L1 intervention cause delays in L2? Absolutely not. Not at all. So let's say that you're learning math. Let's say you're a kid. You know L1 really well, and L2 is what you're trying to learn. It's what the school is being taught in. You're learning in math, find the circumference of a circle, and so you get in there and you read the paper, and it's like, find the derf and gerf for the wing wong, and you're like, I don't know what a derf and gerf and a wing wong are, so I'm just going to sit here because I don't know what the hell I'm supposed to do, right? So if somebody can come up to you and in your language say, it's the circumference of a circle, you just use these, and then you go, oh, I actually do kind of remember that from before we moved here. So then you can actually learn the math, and it doesn't hurt your L2. It only helps the math that you're in currently. And actually, occasionally you can make connections between your L1 and the L2 that you're looking at on the page too. If you know that derf and gerf is circumference, then that's great. You've learned it. So no, L1 intervention does not cause delays in L2. And, that's outside of math too. That can be in any subject. You can supplement any child's education in any language that they use. It doesn't hurt their ability to speak L2 or English. Since we're in the United States, right? It doesn't hurt their ability to speak English later. So the more L1 intervention you can get them, the better they're going to do across the board academically, including in their L2. Is the semantics. So what word are you using in what situations? Is that correct? And then the use is the pragmatics. This is like the social component of language. Are you saying things that you shouldn't say based on social rules? Like, are you telling people too much of the truth? Are you standing way too close? Are you talking too loud? Or too quietly? All these things are pragmatics or use. Do boys or girls have higher rates of ASD, and why? Yes, boys have higher rates of ASD. Why? Unknown, though there are some ideas, right? One idea is that boys externalize more, so it's just easy to see it. That is something that we see in ADHD and ADD a lot, is that boys externalize more, so it's easier to see that. Another possibility is that typically it's just males that are used as the baseline. So if it shows up differently in males and females, you're kind of comparing only to the male symptoms, basically. So then if it presents differently across gender lines, then you'd be like, oh, well, that's something else. But then these kids, mostly boys, have ASD. So that's another possibility. Where else do we see this? We see this in ADHD. And also just, standard articulatory and phonological issues, boys typically have higher rates than girls. Are rates of ASD diagnoses rising? Yes, they are. Currently, it's 1 in 59. I think like a year and a half ago when I taught this class the first time, it was 1 in 62. So that's not a huge rise, but it is somewhat of a rise. Why? Well, multiple reasons again. Unknown, but multiple possibilities. One of the big ones that we do know that's at least part of it is we're just diagnosing more. We know more about ASD, so it's easier to diagnose. More doctors and more parents know about autism, so they can ask about it or they can think to look it up. They can refer the child to a psychologist who could make that determination with using the DSM. Also, the diagnostic criteria have gotten more specific over time as well. So then with better criteria, you can diagnose more people. Another thing is we used to have different subtypes of autism. There'd be autism, then there'd be like Asperger's. Those are now together. So instead of just looking at rates of autism, then you had like Asperger's and Savant and all this other kinds of stuff. That's all together as well. And then it's also possible that, there is some sort of... So those are some possibilities. A typical person with ASD, what do they look like? Well, you've heard this at least twice now. There is really no typical thing. I mean, really the only typical thing we can say is like the use, the pragmatics of speech are impacted in strange ways. Other than that, though, there is a variety of symptoms that can occur. Some common childhood symptoms: lack of eye contact, no interest in playing with others, including parents and siblings, an extreme focus on one thing, though of course what that is very different from person to person. And then, like I said, again, the use issues. What other disorders co-occur with autism? Well, we've got depression, we've got anxiety, we've got gastrointestinal issues for some reason, possibly linked to anxiety, but also they can just occur on their own. Depression, anxiety, gastrointestinal issues, ADHD and ADD, and those are the big ones, those four. The biggest speech problem for ASD, we've talked about this already twice on the slide, it's use and pragmatics. So let's go to the next slide. This, I think, is our last one. Yeah. So this is ASD in adults. The history of research on ASD in the elderly is just poor. There is not a lot of it, right? That's the whole point of that lecture, was basically like, we need more of this. There isn't enough. We don't know enough about these people. What similarities exist between the brains of people with ASD and the elderly? Frontal cortex shrinkage. This is the big one. Loss of volume in the frontal cortex. Where are most deficits seen with ASD? Well, again, this is basically what I just said. It's, frontal cortex. Most deficits are seen in the frontal cortex. Same with aging. Most deficits are seen in the frontal cortex. If we want to talk about how this is actually impacting people like the symptoms that you'd see from frontal cortex shrinkage is things like interpersonal interaction. So, again, some of that use stuff, depression, anxiety, problems holding attention, focusing, stuff like that. That's all frontal cortex stuff, decision making, etc. So we see those same deficits in people with ASD. We see the same deficits in people with aging. It seems like with the paltry amount of research that's actually being done in the area that as people with ASD age, they just kind of layer on top of each other and have a more poor prognosis than either the elderly or young people with ASD. And lastly, what is overpruning? Well, pruning is something that happens to every brain around puberty time, or even a little bit before that, maybe around 10. And what you typically see with pruning is that there are a lot of neural connections that the brain generates as it's growing. At pruning, some of these neural connections that are not important are dissolved by some sort of enzyme that's released in the brain. And so the ones that are left are strengthened, the ones that are unused are gone. Overpruning is, you might guess now that you know pruning, overpruning is too many neural connections are removed. So remember, we talked about, I showed you that graph of the brains of people with ASD, that at very early childhood, they had much more volume in their brains than neurotypicals. But then after about 10 or 12, then they kind of fell below the volume of neurotypicals. That's the overpruning. So at first they have more brain volume, which should be correlated with even higher functioning. Then overpruning occurs, and now they have less brain volume. And that's when you start seeing, you start seeing some of the symptoms early on, very early on, before pruning would take place. But then you start seeing more symptoms around that time. More symptoms crop up after overpruning, which again, 10, 12, adolescence, puberty kind of time. Okay, and then that is it. That's the end of the, what do you call it? Review. That's the end of the review. Good luck on your exam, and I'll see you at our next class. We're going to start the second section, mostly just talking about various kinds of disorders. That's going to lead us into homework 2, where you're going to deep dive into a disorder. So look ahead after you take your exam about what we're going to talk about, and see if there's any disorders that kind of stick out to you, that you know that you already want to look at, or a disorder that we're not going to talk about that you would like to learn more about. That's what we're going to do for homework 2. All right, good luck, and I will see you soon.